Hi, my dear brothers and sisters. Have a great day to everyone. Today we are going to learn 10th class maths chapter wise. Every exercise problem is as a easy way. Some children are annoyed by maths. Many children are afraid of maths. Okay, maths is a magic. Maths is like a magic. When we watch magic, we think, wow, how did they do this? How is it possible? After the magic, the magician shows us some tricks. How did he does the magic? Then we think, oh, it is normal. We can do the magic if we try to. By using easy tricks, everyone can solve problems easily and quickly. Now we begin 10th class Maths Telangana State Syllabus Maths chapter wise. Our first chapter is real numbers. Real number. Numbers are divided into some types. First one is natural number. First one is natural numbers. Natural numbers. Natural numbers. The counting numbers. The counting numbers are called natural numbers. The counting numbers are called natural numbers. Natural numbers starts with 1. The set of natural numbers is equal to 1, 2, 3, 4, 5, so and so. The counting numbers are called natural numbers. Natural numbers starts with 1. The set of natural numbers n is equal to 1, 2, 3, 4, 5, so and so. Now we are going to second one, whole numbers. Whole numbers. Whole numbers are if 0 including with natural numbers, they are called whole numbers. If 0 include with natural numbers, They are called whole numbers. Whole numbers are represented by the letter W. Whole numbers start are whole numbers starts with whole number starts with 0. The set of whole numbers W is equal to 0, 1, 2, 3, 4, 5, so and so. Whole numbers. If 0 include with natural numbers, they are called whole numbers. Here, look here, natural numbers are start with 1, whole numbers are start with 0. Whole numbers are represented by the letter W. Whole numbers start with 0. The set of whole numbers W is equal 0, 1, 2, 3, 4, 5, so and so. Here, natural numbers are represented by the letter N. Okay. Natural numbers are a subset of whole numbers. N subset W. Yeah, look here. Natural numbers are a subset of whole numbers. All natural numbers are belongs to whole numbers. So N subset of W. Here, so many members confused with whole numbers and integers. Now we are going to integers. Third one, integers. integers. If we add negative numbers, along with whole numbers, they are called integers. If we include negative numbers along with whole numbers, they are called integers. If we include negative numbers along with whole numbers, they are called integers. Negative numbers are like -3, -2, -1, -5, -10, -300, -499. So they are negative numbers. Integers are represented by the letter Z or I. Integers like so and so, -3, -2, -1, 0, 1, 2, 3, 4, 5, so and so. The set of integers Z is equal to so and so, -3, -2, -1, 0, 1, 2, 3, 4, 5, so and so. Look here, if we include negative numbers along with whole numbers, they are called integers. Integers are represented by the letter Z or I. Integers like -3, -2, -1, 0, 1, 2, 3, 4, 5, so and so. The set of integers Z is equal to so and so, -3, -2, -1, 0, 1, 2, 3, 4, 5, so and so. Here, natural numbers are a subset of whole numbers. Whole numbers are a subset of integers. N subset W, W subset Z. Okay. Natural numbers are a subset of whole numbers. Whole numbers are a subset of integers. So N subset W, W subset Z. Look here. So many children confusing with whole numbers and integers. Now some simple logic, find out what is integers, what is whole numbers. Whole numbers are represented by the letter W. So W has 4 lines. 1, 2, 3, 4. These lines we arrange a shape. The shape comes into this type. This is like a 0. It's like a 0. Okay. So we find whole numbers are starting with 0 and integers Z are I. These letters have 3 numbers, 3 lines. 1, 2, 3. 3 lines. These 3 lines we arranged into some shape. They comes into plus 2 lines. 1 line comes minus. Whole numbers are starting with 0. Integers are starting negative numbers and positive numbers. So this simple logic we can find what are the whole numbers, what are the fourth one, rational numbers. Rational numbers. Rational numbers. Rational numbers. If Q not equal 0 and the numbers in the form of P by Q. They are called rational numbers. Rational numbers. If Q not equal 0 and the numbers in the form of P by Q, they are called rational numbers. Here P by Q, P is equal to numerator. Q is equal to denominator. P numerator, Q denominator. Q denominator not equal 0. If Q not equal 0, denominator not equal 0, in the form of P by Q, they are called rational numbers. Rational numbers are represented by represented by the letter Q. Rational numbers are represented by the letter Q. Here, so and so, -3, -2, -1, 0, 1, 2, 3, 4, 5, so and so, 11, so and so, 123. These are integers. These numbers appear only they have only numerator, but every number has 1 as a denominator. -3 by 1, this is P by Q form. -2 by 1, this is P by Q form. -1 by 1, this is P by Q1. 0 by 1, 1 by 1, 2 by 1, 3 by 1, 4 by 1, 5 by 1, 11 by 1, 123 by 1. Now, these are in the form of P by Q. So, the numbers are rational numbers. So, natural numbers, whole numbers and integers. Natural numbers, whole numbers and integers. These numbers are belongs to rational numbers. Rational numbers can be expressed as a terminating decimals. Terminating decimals or a recurring decimals. Rational numbers can be expressed as a terminating decimals or a recurring decimals. Look here, 0.1234 and 1.3333. This number write as a 1.3 bar. Next, 2.123. This number write as 2.123 bar. So, rational numbers can be expressed as a terminating and recurring decimals. Terminating means comes 1, 2, 3, 4 times same number. Recurring means they are end once 2 numbers, 3 numbers, 4 numbers, 4 decimals, 5 decimals. At the time they end with decimal number. So, they are recurring. Natural rational numbers. Natural numbers a subset of whole numbers whole numbers whole numbers whole numbers are a subset of integers integers are a subset of rational numbers. Natural numbers are a subset of whole numbers. Whole numbers are a subset of integers. Integers are a subset of rational numbers. So, n subset w subset I z subset q. Okay. N subset w subset z subset q. Fifth one, irrational numbers. Irrational numbers. The numbers which cannot be written in the form of p by q are called irrational numbers. Irrational numbers. The numbers which cannot be written in the form of p by q are called irrational numbers. Irrational numbers are represented by the letter q dash or s. Irrational numbers are represented by the letter q dash or s. These numbers are non-terminating non-terminating or non-repeating numbers. Sorry, non-repeating decimals. These numbers are non-terminating or non-repeating decimals. Example, root 2, root 3, pi. Such numbers root 2, root 3, root 5, root 6, root 7, root 10, root 11, so and so. Not perfect square root, square root of any not perfect square integers. Look here, such numbers root 2, root 3, root 5, root 6, root 7, root 10, root 11, etc. Square root of any not perfect square integers. So, suppose root 4, this number as a perfect square integer. Suppose root 4 is equal to 2 square. This is 2 square. Root 4 has 2 square. Root 4 has perfect 2 square. So, this is rational number. But root 5 has not perfect square integer. Root 5 has not perfect square integer. So, this is root 5. This is irrational number. These numbers like 1.231456247138552, so and so. These numbers are like this, not terminating, not repeating decimals. These numbers don't have non-repeating or not terminating numbers. So, this is called irrational number. Irrational number has no subset. Irrational numbers has no subset. Okay. Now we are going to real numbers. natural numbers, natural numbers, natural numbers n, whole numbers, whole numbers w, integers, integers, z, rational numbers, rational numbers, q, and irrational numbers, irrational numbers, irrational numbers q dash. All together, all together, all together, real numbers, real numbers. Look here, natural numbers n, whole numbers w, integers z, rational numbers q, and irrational numbers q dash. All together real numbers. Natural numbers belongs to real numbers. Whole numbers belongs to real numbers. Integers belongs to real numbers. Rational numbers belongs to real numbers. And irrational numbers also belongs to real numbers. So these numbers all together in real numbers. Now we are going to one table. Okay. Look here, these numbers all in one table. This is natural numbers, natural numbers, natural numbers n, 1, 2, 3, 4, 5, so and so. Okay. Now whole numbers, whole numbers w. These are 0, 1, 2, 3, 4, 5, so and so. These are whole numbers. And then integers, integers, integers z, so and so, -3, -2, -1, 0, 1, 2, 3, 4, 5, so and so. These are integers. Then we are going to rational numbers. Rational numbers, rational numbers. Q, so and so, -3 by 1, -2 by 1, -1 by 1, 0 by 1, 1 by 1, 2 by 1, 3 by 1, so and so. Also minus 5 by 7, 8 by 6, 8 by 17, 22 by 7, 1.2314, 3.4 bar, 1.123 bar. So these numbers are rational numbers. Now then separate numbers are irrational numbers. These are separate numbers. These numbers have no subset. Irrational numbers. Irrational numbers. Q dash. These are root 2, root 3, root 5, pi, so and so, etc. Now these numbers all together real numbers, including with irrational numbers also. These numbers are belongs to real numbers. Real numbers. Okay. Real numbers. Now understand. Natural numbers, whole numbers, integers, rational numbers, and irrational numbers all together goes to real numbers. Total, these numbers are total belongs to real numbers. Now we are going to a topic of real numbers, Euclid's division algorithm. Euclid's division algorithm. Euclid's division algorithm. Positive integers, a and b, there exist pair of unique pair of whole numbers Q and R satisfying A is equal to BQ plus R 0 less than or equal to R less than B. 0 less than or equal to R less than B. Okay. Euclid's division algorithm. Positive integers a and b, there exist unique pair of whole numbers q and r satisfying a equal to bq plus r, 0 less than or equal to r less than b. Now we are going to 40 division with 30. Divide with 30. 40 divide with 30. Okay. Now 30 ones, 30, 0, 1. Look here. This is a dividend. This is a dividend. Dividend. This is one is quotient. Quotient. 30. This is divisor. This is a remainder. Okay. Now we are going to dividend blocks A. This is A. Suppose dividend is A, divisor is B, then quotient is Q, remainder is R. So now we are going to dividend. Dividend is equal to divisor into quotient plus remainder. So dividend is A equal to divisor is B into quotient is Q plus remainder is R. Okay, A equal to BQ plus R. Okay, this is a formula of Euclid's division algorithm. Look here, A equal to BQ plus R. This comes A equal to BQ plus R. This is a formula of Euclid's division algorithm. Okay, now look here, 10. Here 10 is remainder. Remainder always comes greater than 0 or equal to 0, but don't comes less than 0. Okay, remainder is 0 less than or equal to r. Okay, or always r greater than 0 or equal to 0. Greater than or equal to 0. R always greater than 0 or equal to 0, but don't comes r less than 0. R less than 0. These don't comes. So r greater than 0 or r equal to 0. So this is formula 0 less than r or less than or equal to r less than b. B is divisor. Always divisor is bigger than remainder. Okay, divisor always bigger than remainder. So r less than b. So divisor always bigger than r, remainder. Divisor always bigger than remainder. Okay, 0 less than or equal to r less than b. This formula comes here. This is Euclid's division algorithm. Euclid's division algorithm used to compute the highest common factor HCF highest common factor of two given integers. Euclid's division algorithm used to compute the highest common factor HCF. HCF means highest common factor of two given integers. Suppose 40 is one integer, 30 is one integer. So this HCF is equal to 40, 30. 30 ones are 30 minus 10. Okay. Next here is 10 is as a divisor. Okay. Now divisor 30 is as a dividend. Next 10 3s are 30. Okay. Remainder is 0. Okay. This problem is over. So remainder is 0. So problem is completed. Okay. Now 10 is HCF of 30 and 40. Here A equal BQ plus R. So A 40 equal BQ 30 into 1 plus 10. Next 30 equal 10 into 3 plus 0. So 10 is HCF of 30 and 40 integers. Two integers 30, 40. So their HCF is 10. Okay. Euclid's division algorithm used to compute the highest common factor HCF of two given integers.